and or sponsoring, contact us. So with that, just no further ado, I wanted to introduce David Bradford. David and I have just recently met, but also wanted to say thank you to Yodle for the food, sponsoring the event, and also just sharing best practices, sharing their practices, particularly from a quality perspective. So David was previously, I think, at IBM and has been at Yodle for
about 2.5 years.
Very good.
So first off, welcome everybody to Yodle. We are very excited to have you all here. I need to give one little preface. I have been a little ill, and I'm just getting over that. So if I start coughing in the middle of this, be warned. I'll be okay. So front row may have been bladder. So Yodle, we do online marketing. We're trying to automate all the online marketing needs for small businesses. We are hiring. It was on the previous slide. We are hiring in all our tech staff. There's little descriptions of some of the positions up here, but software engineers. I think we have a security test engineer, and software engineers in test, which is very close to my heart. I'm one of our software engineers in test here in Austin. And I'm going to talk a lot during this whole presentation about our technology and what we work with here in Yodle. And because I'm a software engineer in test, I'm going to talk about it with quality in mind. So this is going to kind of be in 3 parts. First off, I want to talk about Yodle's kind of journey into microservices. Like I said, I started here at Yodle about 2.5 years ago, and we were nowhere near microservices at that point. And kind of our first steps. So in the beginning, we had a big kind of monolithic web app. At some point, people started thinking about kind of breaking stuff up, and they broke it up into kind of a service-oriented architecture with a bunch of services. But it was still we're going to deploy all this at once. We're going to test all this at once, and we're going to make sure it's okay. And then on Monday nights, we're going to push it all to production and cross our fingers and hope everything comes up when people start coming in on Tuesday, that everything works. So one big deploy once a week. We had around 10,000 regression tests at that time. We would run over the weekend. We would come in Mondays, and we would frantically try and find where all the failures are and what's wrong with them, and deploy this giant web app as soon as we figured out all those failures. So we'd do that once a week. That was kind of our cadence, and that had gotten down from I think 4 weeks at one point. But this is when I came. This is where we were at. Monolithic deploy, one giant deploy with a huge web app. Everything gets deployed at once. 10,000 regression tests that we had to go through every day or every week. And so we decided that wasn't how we wanted to work. That was the regressions and kind of that certification takes a lot of time. If we get delayed in that for some reason, we can't figure out the failures, then our deploy gets pushed back. And so then the business was expecting some feature to be delivered. Well, it's not being delivered on Monday night anymore. Now it gets pushed back to Tuesday or Wednesday or whatever it takes us. And we just have tons of changes we're trying to certify at the same time. So figuring out what's breaking what is really difficult. So we wanted to move to something better and more modern. So we started this idea of what we called ODR, which is on-demand releases. And we started with a few kind of of our newer services that were kind of clean and didn't have all the dependencies that kind of everything in this monolith had. And what those were, they were kind of standalone services that we could verify that they worked independently of everything else, and we could deploy them and certify them kind of on their own. And so with a lot of our newer UIs at this point, and this started shortly after I joined, we started to kind of break these apart and just kind of on the edges with this new stuff. We started to break them apart and kind of create their own kind of deployment and release for that, which was great for these services. We could now certify that they worked. It wasn't this huge, long, weekend-long marathon of let's get all these tests passing. But it was a much shorter marathon for let's get the test passing for this service. Or let's get the test passing for this UI. And then we could deploy those at any time we wanted instead of having to wait until that weekly release came. But this isn't, this was a much better improvement, but it caused some problems with like, now we have to support all these different types of deployments. So we use Play for our UIs. We had to support how to deploy a Play app to production. Our services were thrift services. We had to support how to deploy thrift services standalone to production. There's some other services we have in our render stack that use Python. We had to support those differently, how to deploy the Python services. So, this was a lot more progress. Now there's all these different deployment strategies we had to know. And usually only like one person knew how to deploy a certain app because that's what they built. And so if they're out or sick or left, then someone else has to kind of dig around and figure out what's going on if anything goes wrong. But like I said, great progress here, but we wanted to kind of like push it more. And so we heard about this idea called microservices. And that's what we've been moving to for the next little while. And this is where we're at right now, and this is what I want to talk about today. So with microservices, we're still doing where services are standalone, like in the ODR world. We can test and verify that service independently, and we can deploy it to production. But with all this kind of microservice-y ideas, we're able to do a lot more to streamline our certification, to streamline our deployments, and really make it a lot easier for like anyone to follow to understand the process and follow the same process and like get their app or their service or whatever it is into production without needing experts, without needing like our DevOps people to come and like walk them through it, or to set up a new box because we need a new box for this new technology or any of that. They can just do their own thing and deploy it. So a little bit about like what we moved to and what kind of made this all possible. There's three kind of big technologies that we're using. One's already been talked about a lot today, and that's Docker. So just real quick, because it sounds like everyone, or most everyone knows what Docker is, but Docker is a little like container that you put your app in, and it runs in that app. So it's almost like kind of a virtual machine type thing. And then Mesos. Mesos is kind of so we don't use Amazon. Well, we do use Amazon in some places, but for the most part, we're not using like Amazon or Google. We're just running it on our own hardware. And so we use Mesos, which is, they call themselves a distributed systems kernel. And we use it in conjunction with another service called Marathon. But basically, Mesos, you get a bunch of what they call Mesos slaves. You install it on a bunch of machines, and they're basically like blank slates for you to go and put your Docker containers on. And Marathon is going to schedule, help you figure out where to put your Docker, where your Docker containers can run. So this is kind of an example, and I stole this from the Marathon website. So each of these boxes here, you can think of as a Mesos slave. And each of the small colored boxes in the middle is a Docker instance running on that slave. So you can see you have a couple different services, and you can have multiple instances running. And what Marathon will do when you say, I want to deploy this new service or this new Docker app, it will go and find one of these. You give it like the requirements, I need this much CPU and this much memory. It goes and looks at all these Mesos slaves and finds a place where it can run, and it'll start it up running on that slave. Which, with Docker and Mesos, it makes deployment so much simpler. With Docker, you don't have to worry about all the dependencies and putting everything on the boxes and having like custom boxes for different types of environments or different types of technologies you're using. You just put all that in the Docker container. With Mesos and Marathon, you don't have to worry about any deployment stuff. You just have a bunch of boxes that all look the same, and Marathon and Mesos figure out where to put them and how they should best run. It also does a lot of cool stuff like scaling. You can tell I want 3 instances of this Docker service, and it'll put 3 instances out there for you. or if you want to scale down or dynamically scale, I believe it supports all those type of things. It also does things that can be very useful, like if an instance dies, it can detect that it's died and restart it, which can be good or bad depending on your why it died. But it gives us a lot of flexibility in our deployments to like make it easy for everyone to kind of have really powerful deployments without having to know all the details about what's going on. So like I said, we use Docker. We have a bunch of kind of base Docker images that we built and some templates that like we've added a lot of kind of tooling and support to do some really cool stuff that I will be talking about later on. But we have we've got a bunch of them right now. Java 8 that uses Spring Boot is kind of our most common one and has support for all the latest and greatest stuff. We have a Scala one that uses HTTP, and we have a lot of engineers, these three right here, that are doing a lot of work to kind of like make sure that that Scala one has the same level of support as the Java 8 one. We have some Node.js ones that I'm not sure, I think some of our teams in New York are using those more. And then there's I know some people are working on Clojure ones. I'm not sure the current state of that, but it's kind of being worked on. I think there's other ones people are working on. Like I said, there's some Python stuff. And then, but with Docker, it's great, so people can work on those and build them, and like, it's very isolated, and so it doesn't affect other teams as much. So like that's kind of our architecture, and that's what we've moved to. Are there any questions about that? Yeah.
What is the base OS underneath Java 8? Is it Ubuntu?
I think it's Ubuntu, yeah.
Okay.
Other questions? Yeah.
How does your load balancer find these instances? What other kind of software do y'all use?
HA proxy.
Yeah, we're using HA proxy for routing.
So Marathon will find a machine and then it calls home to register itself with HA proxy, or?
That
Yes,
sounds
there
like
is an agent.
What's that?
There is a GitHub plugin for HA proxy, which Java could use to have.
Okay.
You can use Bamboo.
yeah, we use Qubit. Bamboo Qubit is somewhere in there too.
Yes, it is somewhere in there.
Can you tell us what it does?
Yeah, I think it's HA proxy. Other questions? Okay. So now we're going to get to the more interesting part of this. This is kind of all background up to this point. But I want to talk about quality and how, so, excuse me. When I came here, like I said, we were running this monolith and 10,000 tests every week. One of the great things about that, as painful as it was, is that like once all those tests were passing, and we deploy everything together, we could feel pretty confident that what we were pushing to production, like all those tests pass. And so if something goes wrong, like we didn't have good test coverage and like we should just write another test. But we felt pretty confident. We're pretty confident when 10,000 tests pass, like we feel pretty confident that what we're gonna push out is gonna be pretty high quality. With microservices, and I'm a quality engineer, so I said this when we started talking about microservices. One of the things that really scares me, or it still scares me about microservices, is when we give developers the ability to kind of like push stuff to production whenever they want. Them causing failures that can just take out everything in production becomes a much bigger risk. And it can happen anytime and not just like Monday nights when we deploy. And so I really wanted to feel comfortable moving to microservices from a quality perspective. Like I want developers to feel comfortable that when they hit deploy for their microservice, that that they don't have to worry about taking down production or taking down some really important part of our system, that they can hit that button and feel comfortable knowing that everything's going to be right and everything's going to work how they expect it to work. And because we're not running these kind of like full integration tests in the microservice world, otherwise we lose a lot of the benefits to microservices. If you had to click your deploy button and wait 8 hours for us to do a full integration, like a full regression test, and then hopefully nothing fails, because we'd have to retry some tests or debug them. We would like never deploy anything. But there's a lot of things like we've kind of been pushing and trying to do to kind of like get that confidence and maintain that quality. And so that's what I want to talk about next. So a lot of this is, first section is automatic tooling. This is stuff we I talked about in our templates. This is stuff we get out of the box, out of those templates most of the time, or it's like very little work to get it. The first one is static analysis. Yes, that question?
So to me, it sounds like the real initial challenge of microservices is defining the contract between the services and being extremely specific about what that contract is.
Yes, that is a challenge. I will be talking about that very shortly, or maybe not very shortly, but I will be talking about that eventually.
Because to me, that's the governance issue. If you do that wrong, you're screwed forever.
Yep.
I wanted to ask
Yeah.
a quick question. I think you're going to get to this, it sounds like it, but I was curious when you mentioned just a minute ago that one of the things that really concerned you with microservices is the fact that developers can deploy to production, and that would bring the whole thing down.
Yeah.
I'm not an expert in microservices, but I thought one of the philosophies behind microservices was the fact that if you take down one of the microservices, everything is still good to go. Versus
If you take down the service, but if you introduce a bug in the service that breaks everything, it will still break everything.
Gotcha.
And
Okay.
so that's more what I was referring to rather than like the service like crashes.
Okay. Cool.
Other questions? Yeah.
You solve the fragility problem by pushing up, just partially pushing up the version, like leaving 2 of the old version running, push up the new one, see that nothing breaks? Or do you wholesale replace a microservice?
We will be talking about that in a bit. It's coming. Spoilers. Um,
I'm being a straight man, not spoilers. Okay, straight man.
So one of the first really easy things we did, or one of the things we did that's really easy is static analysis. And there's a bunch of ways to do this. So like I said, we do a lot of Java, and SonarQube is a good Java static analysis tool. It generates a website with all the static analysis stuff it found. This is an example. This is kind of pretty recently rolled out. What we want to do once we feel comfortable with it, comfortable that it's finding what we want it to find, and you can customize a lot of the rules and stuff for what it finds. You can also have it break the build. So if you are like tanking quality with your commits, it will just break the build and not let you like merge that. So that's a really easy way to get a like really easy win quality wise. Next, Jacoco. So again, this is code coverage. Jacoco is the tool we use. It stands for Java Code Coverage. I'm not sure if we have it for other languages. I'm sure there's stuff for other languages. I'm just not sure if Jacoco does any of them. But this is for unit testing code coverage. We will fail builds. Like this is automatically built into the template when you download it. If you look here, so this threshold is 80%. These 2 classes are around 60%, so it failed to build. So code coverage is something with our microservices we are like enforcing hard. It's we say 90%. I'm not sure why this one's 80%. We say 90% on all new services need to be that way. Just because like you should be doing unit tests because it's a good thing to do. Next, monitoring alerting. With microservices, that becomes a lot more important because we are pushing to production a lot more. We need to see what's going on. When things do happen, we need that. We're using New Relic for this. I'm not sure I don't know this space very well, so I'm not sure what other tools are out there. But New Relic has worked pretty well for us. You get lots of colorful graphs about what's going on. You get throughputs. You get transaction times, which is really useful. Errors. And it has a lot of pages. You can click through it and get more details on all this stuff. But because we're pushing to production so much more, being able to see how production's running and making sure nothing is going crazy. We also have it hooked up into OpsGenie we use, where if something does go, if I push something to production and suddenly the error rate spikes, New Relic will detect that and it'll ping whoever's responsible for that app, so they can they don't have to be watching New Relic all the time. If something goes terribly wrong, they're going to get notified, and there's escalations and all sorts of stuff.
How do they get notified? An email or
Our manager comes over.
So we use Ops Genie. It's customizable. You can configure it however you want to get notified.
Yeah.
You can do email, text message. There's a phone
Okay.
app. It can call you if you want. Hip chat. There's a hip chat plugin. Yeah, so it's customizable. If you don't respond to it, then it's your manager coming in and telling you that you need to do that.
So what kind of events trigger
It's
notifications?
in New Relic, it is configurable, I believe. I think we have error rates like greater than some value, like 5% maybe. And it's every application you can configure differently depending on the like needs of that application. So you can do like error rate. New Relic has this idea of apdex, which they kind of, I don't know that they say exactly what it is, but it's like how happy users of this service would be. So if the response time goes way up, the apdex will go down. If its error rates go up, the apdex goes down. Its throughput goes down, the apdex goes down. So it's this top box up here. I don't know the exact formula they use for that, but they try and like take a picture of everything and compose it down into one number. And so you can get, if the apdex score goes below like, I guess it's 0.9, it can alert you. Or you can alert on like, I guess for microservices it might not matter, but like memory usage and CPU usage. We also use it to monitor our hardware as well. That stuff's more useful there. But it's pretty configurable that you can like, whatever you want to get alerted on, you can get alerted on. The trick is just finding out what those values are, because you don't want to be alerted like for every little thing. But if it's something important, you want to be alerted about. So
Is these errors in the production one?
this is all in production. Yeah, this is just in production stuff.
So, just a side note on that, like, all the newer orchestration systems, and even with the newer version of Docker, they're providing this fluent delogging, which actually, using that fluent D APIs, you could actually log the metrics that you want, including, and we actually use it for performance tracking on how each request, how many seconds would each request take to all the way from if there is any logger, we still use that fluent delogging to actually tell us.
Cool. Next is Cabana, or logging. Goes right along with that. So I'm gonna make a confession right here. Cabana is what we're using for logging. We just rolled this out and I have not used it very much, so I am very unfamiliar with it. I played around with it a little bit and it seems really cool. It does a lot of stuff that I don't know yet. So I sometimes, we log it in two ways. We throw all our stuff in Elasticsearch, and Cabana gives us like the front end where we can do all sorts of fancy searching through the logs. We throw all the logs on an NFS mount, and I usually just go SSH onto a box and get on that NFS mount and search through logs that way. But I'm old fashioned like that. So yeah, logging. Again, we get it for free and with the kind of templates we have. But there's a really useful thing to have when we do see problems that we can go like dig down in those logs and figure out what's actually going on. And Cabana does a lot of really cool stuff. I've seen like people that know how to use it demo it, and they can like find really fancy stuff really fast. So it's a good tool to invest in, it seems like. But that's the end of this section. So these are kind of really automatic tools that we just kind of get. And we get a lot of really useful information from them that really helps us to kind of maintain and grow our quality for these microservices without hardly any work at all. I think the biggest one is, as part of our build plan, we have to tell it to run Sonar. Yeah?
So the last two features, Cabana and New Relic, those
Yeah.
are not Java specific. First couple were Java specific.
The actual tools we use are Java specific. Most languages will have tools like that for them.
I understood,
Yeah.
I'm just trying to understand the things that I could apply.
Yeah.
The New Relic stuff and the Cabana stuff, I could apply.
Mhm.
I'm not gonna use Java, sorry.
Yeah, that's fine.
I'm happy to let the stack run, but I don't need to actually ever write any code. Correct. That would suck. Okay.
And a lot of that is built into the base, our Docker image, like our Java 8 Docker image. Configures the New Relic agent. It
Yeah.
configures where the logging to go to the syslog that eventually makes it out to here.
Yeah, most of the stuff we just, if you grab our Docker image that one of our teams built, you get most of the stuff for free. So yeah, teams are already getting this, which is really, really nice, and one of the benefits of using Docker. So next I want to go into our testing pipeline with with microservices. So I don't know how many like test nerds we have in here, but if you ask like most QA engineers, there's this idea of like a testing pyramid. I can probably draw. So this is in the ideal world. You'll have like unit tests down here, some sort of like functional tests here, and like integration or like end-to-end tests up here. So you want a lot of unit tests because they're easy to write, they're fast, they can just hit a lot of cases. Functional tests, you want a lot of these still, not as many unit tests, or integration or end-to-end tests. You want some of them, but not quite as many, because as you go up this, you're going to cover more, but they're going to start to get slow and brittle and hard to maintain. Whereas you go down, tests are going to get a lot faster and easier to maintain and all that stuff. With our monolith, and I did this in an earlier presentation a few days ago, we were more, instead of a test pyramid, we were like a test hourglass. If we were lucky. We sometimes had a lot of unit tests, but we had a lot of these kind of integration end-to-end tests. And like no tests in the middle. So that's part of why, and this is very off, because we had a lot more integration tests than that. That's part of one of the challenges. As we were taking on microservices, we wanted to get more to the actual pyramid approach and less to the sandglass approach. So we did that, or that's what we're trying to do. Like I mentioned on the code coverage slide, unit tests are kind of our first line of defense. We have a 90% code coverage requirement. We enforce it via Jacoco with our Java apps. I'm not sure what we use for other languages. I'm sure there's stuff out there. But yeah, we're expecting all our developers to write unit tests on all the new services, 90% code coverage, and that, if I see people trying to like change that, I like yell at them a lot. That's true. Yes. The next step we have is, we call it functional tests. So I like to think of these as unit tests for like the whole service. And these again, they're run as part of our build process. We expect them to be 100% reliable. I'm going to talk about the Spring Boot ones because that's kind of what our best supported ones. When we like I said, so I think of the functional tests as unit tests for the service. So we mock out any external services that this service is going to call out, and then we're going to test these endpoints with those mocked out. First, Spring Boot does a lot of magic behind the scenes that helps us do that. It makes it really easy to mock those out, and it has a test thing that we can start it up. It'll start up an instance of that app with the mocks there that we can run our tests against, which makes it really easy to not have to worry about like what's going on. It just starts up the service with the other endpoints mocked out, and we run our tests against that and make sure they all pass. One interesting thing, and we kind of went both ways with this, is with data stores. If your service is talking to a data store, we can either mock out the data store and use like an in-memory data store, or we have it so you can actually run against like a dev version of our data store sitting in our data center somewhere. You can do either one. Depending on the service, you might prefer one or the other, but we do support both of those. So these are great. I'm going to talk more about these in a bit and some of the ways we use these, but these are really important tests, and we're hoping kind of take a lot of the integration tests should have been these, and so we're trying to drive these a lot more. Question?
So is this where you're defending your contracts?
And
are these written by someone who didn't write the code?
They are where we're I'm going to talk about contracts in a minute. These are usually going to be written by the same person, but not necessarily. Is there another question? Or okay. Next, consumer-driven contract tests. So this is what you were asking about. These right now we're implementing these via functional tests. But these are contracts. Basically, when you have an endpoint and a microservice, this is a test saying that that endpoint does what it is expecting you to do, or what some consumer is expecting of it. These are really important for us to reduce our reliability on our integration tests. And one of the kind of rules we have, so if you have two services, and I think we're going to talk about this. Yeah. So if we have two services, one service is a consumer of another service, what we want is if it's expecting, so this is just a get clients, what to do. So it's expecting that endpoint to return something or to do something or whatever it's expecting that endpoint to do. It should be, whoever is writing this consumer service and like expecting that endpoint needs to ensure that in this provider service, there is a functional test that calls that endpoint and verifies that it returns successful or it does something or it returns something. Whatever it's expecting, it needs to verify that like that is the contract and there is tests verifying that that contract is there. And so that's kind of how we have right now. What we're doing right now for our contract test is it's just a functional test that the consumer service is going to put in the functional test for the provider service. Does that make sense?
So the writer of the consumer service typically writes the functional test for the provider?
The provider, whoever writes the provider service should be providing some like basic tests as they write it. The owner of the consumer service should go in there, make sure if it's relying on some functionality that those tests either exist or add them if they don't exist.
So I guess is that question, how do you provide kind of maintainability of tests over time? Like how is that ownership handled within Yodle? So because for example, right, like as you have these individual kind of services, right, that are, you know,
Yeah.
very specific, providing their particular like function, right? You're gonna have maintenance over time, right?
Yes.
You know, so once again, for example, say if a contract gets updated, right? How do you maintain basically the dependent services and also the dependent tests here, right? Because when you start off with it, that's a simple use case, right? Now
Yep.
we're talking about, you know, technical debt over time in terms of maintainability. So how do you manage that within Yodle right now?
So one is keeping services like very small, and so they don't like, so we can like keep that maintenance cost down. Also, what we've found so far is mostly the team. It's mostly kind of that we like our microservices tend to group around like an area. So like one team's gonna be working with a group of microservices, and they typically aren't gonna work a lot outside of that group. And teams don't typically come inside and work in that group. It's kind of like, so like if we have a billing system, for example, there's gonna be a set of billing microservices that are gonna work very closely with one another. And the team that works with those is gonna work a lot with those tests, with those services. And outside teams don't typically come into that a lot.
If I could maybe just, sorry to interrupt, but
Yeah.
just phrase the question a little bit differently, right? I mean, you gave a great example of your monolith, right?
Mhm.
And the amount of kind of, you know, hourglass, you know,
Yeah.
like, you know, wrong heavy, right? Of course, you know, what that also implies, right, is basically the technical debt in terms of maintenance of those tests, right, for that monolith is also very heavy, right?
Yeah.
So I guess as if you say within this one group, say this one billing group, right, as basically these services evolve over time, right, how have you guys structured yourselves to basically decrease the technical debt in terms of maintaining these, you know, contract-driven types of tests? Or how has that been or not been an issue?
If I may
Yeah.
talk to that briefly. So, I think there's a couple things here. One David mentioned, our goal is to keep microservices fairly small, and so we can manage that and have some overview, a full understanding of what's going on. And the other thing I want to point out, and it's kind of a two-step process, this is really new. So we recognize the issue. And the third step is Yodle has an outstanding QA department takes this kind of feedback and finds solutions. So these are evolving, ongoing progression, and Yodle is really committed to and empowering people like David to let these things.
So I guess as a quick segue, Brian? Richard, sorry, Richard. So in here, right, I mean, where do you picture the ownership then being over time, right? Because originally I think you mentioned here that, you know, these tests, right, this functional test for this particular provider service will probably be created. Is it by the individual, or are you saying it's by the team that's actually?
So it's by the team,
Okay.
and then we'll, as well, part of the conversations we've had is we hope to have some tooling around that can match these things up and tell us when we've broken this kind of contract.
And
have you seen that very often? I guess that's a great follow-up question then, right? It's like, I know this is something that you've just been starting off.
We haven't seen it a lot yet,
Okay.
and I will be talking in a little bit about, so this is right now is like what we're actually doing. In a little bit I want to talk about like what we're planning on doing, and we're still kind of building it out, and we'll address that specific issue in that.
So do you use technology like Cucumber or something for these contracts?
We don't. We've just been writing them in Java.
Because actually Cucumber, like if there are any duplicate tests or if there are any relevant tests that you need to perform with the functional test, actually Cucumber has a way of scanning those, like especially when your Scrum Master or someone is writing stories which are feature driven, they actually write it in plain language. And if you see the matching pattern, something like Cucumber can actually say, hey, there is already one feature file that has this feature, so do you want to use that instead?
I think the challenge that I'm kind of thinking through as, you know, we're utilizing kind of like microservices really is almost kind of the point of dependency management, right? Because you're going to have these set of services. I mean, this is a very simple diagram, right? But once you start getting into, you know, hundreds of different services, right, and leveraging that, right, there's going to be a set of dependencies and a set of tests that need to be maintained, right? But then this is in a very efficient fashion, just like, you know, using your IDE to basically do something like simple refactoring across your whole entire code base, right? So to me, it's like the next evolution is something like this would be like creating a set of tooling, right?
Yes.
To help basically that.
So we,
Yeah.
so we have stuff like as we have these groups of services he's talked about, we have tooling that like on our regression tests or any of our tests actually gives us a report and it's bucketed per team. So the QA team takes every test and they assign a responsible team to monitor that test, looking at like who that impacts, who originally wrote it, and all those factors. So we have a reporting tool that like emails whatever team is responsible and kind of coordinate to say, am I responsible for this contract update, et cetera. So that's happening on a daily basis.
Yeah. I'll talk about in a little bit some more tooling we're working on that is not quite out. It's just getting started. Let's go. What question?
I think you already answered it. You said that you're expressing the contract tests in Java.
Yeah.
Are you using some sort of documentation tool, something that can generate the tests themselves?
We're using Swagger for our documentation, which I didn't mention. We haven't looked at it for generating tests yet, but I know it's been talked about. We just haven't investigated it. So, another question?
You may be getting on this later, but what about performance, about slowdowns and stuff like that? You test at this level, or you have something else you do?
We do not test performance at this level. Our tests, so we have the logging helps with performance, and then typically we haven't been particularly great at performance testing. We do mostly performance testing on like on an as-needed basis. So if we're rolling out a new something, and we want to make sure, like if we're replacing something, we want to make sure that it's as performant as our old thing. We'll do performance testing of that when we're getting ready to ship that feature or the new replacement. Yeah.
So reprising my straight man role, what do you do about in your architecture process about microservice failure? How do you architect your system to be robust in the face of failing nodes?
For us, Marathon and Mesos kind of gives us that. If it detects failing nodes, it will bring them up on different nodes. It'll bring up, if it detects failing instances of a Docker image, it will bring them up on other Mesos slaves. We'll probably, like, and then New Relic should start alerting us that there's all this stuff failing, and we can go and investigate what's going on.
Right, so that's great. Where my question is coming more from your design of microservices and clients and servers, or clients and producers, consumers. How do you have any pattern that you use inside the design of your microservices to be resilient for when the client or the producer goes away while you're in the process of connecting to it?
We have not defined any like hard requirements for that right now. Mostly because it depends a lot on the specific service. Like some services that like are really important, if it goes away and we can't get a response to it, we need to fail that operation and we just can't move forward with it. And that's the approach we've been taking thus far. With some others failing more gracefully or running into a great state, we could do that. I don't know if any teams have been doing that right now.
We use the Hystrix for some circuit breakers in places. I don't know how widespread that is. But yeah, I mean, if the database goes down, then, you know, bad stuff happens. People.
Yeah, so David, maybe I'll say this, and you might even be able to
Yeah.
move off this slide, but maybe not. The discussion is fantastic. And Matt just said, or actually the comment that I was going to add, which is, I'm not sure if this is kind of what we're hinting at or kind of looking for, but circuit breakers, I think you mentioned districts as well, but circuit breakers as a pattern for when you're architecting those things. How do you make sure that when one of these things go down, the whole system just isn't so brittle, but rather, hey, one of these things go down, you can fail that duty failed, but still there's some amount of functionality, whatever makes sense. And so that's just the circuit breaker as a philosophy towards.
Right, the general pattern you're going to be using in some sense as you develop these services and build like confidence in these services. Part of that confidence comes from actually knowing that your individual pieces are robust in the face of failure. This goes back to Joe Armstrong and the Erlang papers, which are about software being unreliable, right? You have to design in the context that your software sucks, right? And all of our software sucks, not yours, okay? All of ours sucks, okay? But that's an important design principle for systems that scale, systems that are robust and resilient. And that's where,
Yes.
that's all is where I'm coming from. No criticism of you, what you're doing, just trying to cheer you on. That's why I said straight man. Okay.
Yep. Yeah.
So, yeah, this slide generated a lot of discussion.
Yes.
So, I see you guys do not deploy the consumer and the provider at the same time. They can go
We do not. They can go independently.
So, and I also assume that before you deploy the consumer, you run the functional test for the provider.
No, before we deploy so if the consumer is adding new functional tests that they expect the provider to have, they should run those tests. But if they're not, if the provider already has those tests, then we assume they've passed.
Okay. And so the follow-up question then is, if the provider then revs, goes to another version, I don't even know if this is an issue for you, but do you have any cases where the consumer then is running against an out-of-date or a, obsolete? Yeah.
That if
Provider that's moved on.
I mean they can update the versions and whatnot by adding new endpoints. But if they like if they make a backwards incompatible change, say, that's what the tests are designed to catch. Like then those tests will fail, and they need to resolve that before they push that out to production.
Functional tests are also our version, and so the old versions should continue. All the protocols should continue.
Yes.
So you can make this a yes/no question, so you can move on.
Okay.
But going back to this gentleman's concern that he brought up.
Yeah.
Did you guys mimic or kind of look at another company's design of these kind of microservices, or did you just kind of do it on your own?
I think we did a little of both.
Do you mind sharing?
We got a lot. So there's a book. So Riley book. I don't remember what's it. Building Microservices, I think. Yeah, that one. I think we follow a lot of patterns in that book.
Also, there is a really nice article from this guy, yes, Martin Fowler.
Yeah.
That you guys want to check out. This is like, they actually talk about lots of different tests, which I actually saw in your slide.
Yeah, he
Like,
uses domain-driven design in this book, so.
That's one good resource.
Yeah, he's pretty good.
Yeah.
Both Martin and Sam Newman, the guy who put that work, they both work at Towers, so.
Yeah. Okay, so,
Next slide.
yeah. Just gonna go. So the last part, or no, the next part is integration tests, which we've been like really trying to minimize these because we kind of use them as a crutch for a long time. But in some cases, some services, especially groups of services, are really important, and we want these, and they're like, we don't feel safe deploying without them. So we do support, like, we'll deploy an instance into one of our test environments, or instance being changed in one of our test environments, run some set of integration tests against it so we can see it actually interacting with other services, and do that before we actually deploy it to production. Like I said, we are trying to minimize that, do it as little as we can, but if we don't feel comfortable, or if it's an area that we feel like is really vital and we really need that, we do support that. And then the next part of our testing pipeline, I think is really interesting. It's this idea of Canary Tests. So these are actually done in production. We have this idea. Well, I'm going to just go through and describe them really quick and then describe when we run them. So we have two types of Canary Tests. The first is really simple. It's this little bit of JSON, which just has a bunch of stuff. But we define an endpoint. So this is API v1 contacts, and then that value. An interval, which is how often we want this to be run. A default action, which is like if something goes crazy and this test doesn't do anything, what should we do? And I'll talk about what that action is in a minute. What HTTP method we want to do, the payload, so like if there's any values we need to pass to that endpoint, the results from the test. So, and these are going to be the same values as the default action. So this is if, and the result type, which HTTP status code. So basically this says, I want a test that calls that endpoint with this data and does a post to it. And if that returns a 200, I want to do this, which is continue. If I get a 404, I want to do this, which is rollback. If anything else happens, now my default action is to roll back. So that's just like a really small snippet, and that we put in we actually put this in the service. Teams can define as many of these as they want in every service, and there's just I need to think. So
does this happen during your container initialization, or how do you guys coordinate the execution?
I'm going to talk about that in just a minute. We have a second type of Canary test. This one's a little more complicated. Again, it's defined with JSON, but instead of like defining the endpoints and what it expects in the data, it's just giving us the endpoints. And that's pretty much it. The rest of the stuff is just it's kind of the same stuff. Interval, default action. The result's going to be test result, which I'll talk about in a minute. What you're going to call it with. This doesn't have a payload. But that's going to define an endpoint. That endpoint is going to go, it's just going to be basically a test. And it's going to return a test result object, which we define somewhere that's just like, again, a JSON object that says like what the test did. So that endpoint is basically going to run some internal tests in the service and spit out whether they passed or failed. They can give them more information like what passed and what failed and that type of stuff. But it gives you more than just, I hit this endpoint and this is what I got, what got returned. So when these tests run, we have what we call a Canary Flow. And this is going to answer a few questions we've had. When I hit deploy to production, it doesn't just deploy the app to production. We go through three phases. Our first phase is called Canary Isolated, where we will deploy one instance of that app to production. We will not let any traffic go to that app. But we will run those Canary tests. Whatever Canary tests are defined in that application, it will call an endpoint that again, a lot of this is in the Docker image, but it calls an endpoint that gives it a list of all those tests, and then it runs all those tests. All the endpoint tests and any of the embedded tests get run during the Canary isolated. It also does a few other things. It's going to check that this app is reporting to New Relic. It's going to check like some basic JVM stats. It's going to check to make sure this app is like responding at all. So it's going to do a bunch of stuff as soon as to this one deployed instance. And it's going to run those checks a few times. I'm not sure exactly what we have it set right now, but this is kind of the output we see in some of our tooling. Like it checks and there were no errors found. It was deployed, we could find the service, and then it checks it again and again until like we feel like we checked it enough. And then we move to this Canary partial phase. Now at this point we're going to deploy more than one instance to production, and we'll also like let a small amount of traffic go to those instances. And again, we're going to rerun all those Canary and health checks against those instances. And so the same thing as the Canary isolated. So if there's something terribly wrong and your app just explodes when you deploy it in production, we won't get past that Canary isolated. It'll fail, and you'll have to go fix it. If that passes and we get to Canary partial and there's something weird going on, hopefully we can detect that, and that'll fail, and we'll like undeploy it before it gets out into production. If we're passing all our tests and we're not seeing anything bad happen during these two phases, and however many times we requeue that, then we'll push it out to full production, and you're done. That's the version that's in production. So that's when these tests get run, is during this Canary phase.
How long is that phase?
It depends on how many tests you have. It's more, instead of timed, it's how many repeats, how many times we repeat it. I think we repeat it about 6 times right now. So if your tests are like really fast, and all these health checks and everything are really fast, it goes a lot faster. If you have some like long running tests, which I don't think anyone does right now, it would take a lot longer.
Is fast like 2 seconds or is fast like 2 hours?
I think our average deploy is about 10 minutes in a phase right now.
Do you find most of your issues during that partial and the full section, if you kind of had to just take a look back at like the last couple?
What was the question?
Like where do you find like the most issues? Like where you kind of start,
In the isolated.
You find most
Yeah, I think from what I've seen, most times if there's something wrong, we'll catch it there. So, yeah.
So parallel load tests, I mean, forced race conditions, things like that, because we're talking about parallel systems here.
Yeah.
So are your partial tests or Canary isolated actually trying to put the service under test under real load?
I don't think we're doing that right here. We could do that, I believe.
So the follow-up is, do you aspire to run chaos mode?
That I personally think that would be great. We are not at that state right now, and we have work to do to get there. Is there other questions? Yeah.
I just had a question on, I don't know if this comes up for y'all, but on the partial to full, like, is the old version still there once you get to full for a while? Like,
Once we get to full, we tear down the old version and just.
do you ever have any conflicts with that, like at the tear down of the old environment?
I have not seen any.
As long as the changes are backwards compatible.
Yeah.
I imagine, and our timeout from our HA proxy to the service, the REST call, is like 50 seconds. So, or is it 10 seconds? I don't know. But it's a short amount of time. So any REST calls that are in process, within a minute they'll be done one way or another. So within a minute you should be able to tear down the old service.
So if you have changes that modify the contracts, then you have to coordinate microservice compliance testing?
Yeah, if you're modifying the contracts,
Then you have to.
you have to, like, and we purposely do that. Like, we don't want people modifying contracts because that's very dangerous.
That's why you do the work ahead of time.
Yeah.
As much as you can.
We version the API, so we'll create a whole new set of endpoints for V2. And hopefully at some point in the future, when we're sure that nobody's ever calling the V1 endpoints, we could get rid of them, but it's not let's do that right away.
So most of these orchestration tools right now do provide rolling update, and you could use the notion of tagging and like service labels to say which version should this new request go to. So you can use that.
So if you're deploying multiple components that are aware of each other, does the Canary Flow allow multiple components to be deployed at once and then the canaries find each other? Or do you have to do it in a particular order, and as soon as the base case is ready, then you do the next one, and it talks to the one that's already full production, and then talks to the next one that's already full production?
For what we support right now, they would need to be done individually. The method for how this kind of stuff works is like HTTP header passing. We like add a little header to the HTTP. We add a little token to the HTTP header so it knows, and so it gets redirected to the specific instance. Using that, you may be able to do something like you were talking about, where you have multiple instances in an isolated mode, and you would hit all of them on the Canary Tests. But we don't support that right now. But it might be possible. I'm not sure.
Wonder real quickly.
Yeah.
You said that you find most of your issues in the isolated, right?
Yes.
Well, I think that's all, once again, a very positive sign. You're not finding issues in partial or in full production, right?
Yeah.
But are there other things that kind of, as you were learning, that you're finding, maybe we should be finding them even before we kind of get to this testing pipeline?
Well, so most of the issues we see in the Canary pipeline are we see in the Canary isolated.
Sure.
We do catch lots of issues before we even get to this point.
So my question, I guess, at that point was, like, do you feel like most of those issues should have been caught before we even kind of got to this particular testing pipeline, or are these issues that, for whatever reason, due to your infrastructure, right, or whatever it is, right, really would only find itself in this type of Canary isolated environment versus kind of like a local dev build test?
Yeah, so
If you're Dockerized.
I think one of the most common issues we've seen is, and this, we saw a lot more when we were kind of like trying to roll this out, is that the apps wouldn't register with New Relic. There was a common mistake people were making, and so
You didn't have that same configuration in your like local dev build environments? Was that?
they overwrote the configuration to change the app name, so it was looking for a different name than like what the service was registering in New Relic. And those we all caught in the isolated phase, because like one of the checks is it registered with New Relic? Do we see it there?
But it seems like you do a differentiation between kind of your Canary environment versus kind of a local dev build test.
Yeah, you wouldn't see it in we'll only register for the New Relic in production, so you wouldn't see it in any of the other environments.
Okay, that makes complete sense then.
Yeah.
Sorry, go ahead. I didn't raise my hand.
Okay.
I'm curious about who initiates this. In other words, who pushes the go to production button?
I'm gonna show that next.
Okay, cool.
Yeah. Yeah.
So errors in the Canary pipeline, the Canary Flow, to me are extremely serious.
Yes.
That you should never catch error. I mean, it's great that you catch them, that's
Yeah.
the belt and suspenders, right? But does the resulting error flow trigger a human process to look at your process that let that get there? In other words, that should actually go back and trigger something architecturally about your process, in my opinion, that you should say, something we're doing wrong, like that configuration overriding. There should be a standard library or something, because you don't want programmers screwing up configurations, particularly in this flip process.
Yeah.
So my response to hearing of that is like, oh, we have to go codify something that humans no longer touch.
Yeah.
That's what I was gonna allude to just a minute ago, is that it seems like a lot of the tests, a lot of the things you catch in the Canary isolated would be, for instance, unit tests that weren't written. or
Yeah.
something like that, so.
Or you forgot to update the database schema or with the database in production, but you'd done it in QA or dev. So, things like that.
Seemed like in what you were saying, Brett, it's like configuration issues where you know that even though you're, Dockerized, right, there are differences within configuration that still need to be accounted for before you kind of go to kind of a live system.
Yeah. Yep.
Or
Yeah.
if your app crashes after 10 minutes of running because you've only ever run it for 1 minute to run your test locally. I mean, but again, that's a developer process thing, but
Yeah.
catch that.
Yeah, right now I don't think we have a formalized process for addressing when we see these. We have not been seeing I don't think we've been seeing a whole lot of Canary failures.
A lot of the ones I see, like in HitChatter, it's like the the infrastructure team that's building out a lot of the developer tooling and stuff, as they're developing the tooling, they're eating their own dog food. The services that we have that monitor and kind of orchestrate some of this stuff are written in this exact environment. So they're trying to roll stuff out, and I see a lot of rollbacks from them more than other teams.
Just growing pains.
Yeah. I will say, like, I think these Canary tests are really cool. There is one drawback to them, and that's that they are run in production. So writing destructive Canary tests is very dangerous. Most of them are going to be, I don't know what's going on there. Most of them are going to be stuff like gets and like viewing stuff rather than like, there we go. Or rather than trying to like build stuff or delete stuff. So that's one of the drawbacks to those. Okay, so